Example 20. The region bounded by the curve y is equal to 2 over 3x plus 1. The axis and the line x is equal to 1 is rotated through 360 degrees about the x-axis. Find the volume of the solid of revolution formed. All right, first of all, the region is bounded by the curve, the axes, that is the x-axis and the y-axis. The y-axis is the line x is equal to 0. And so the volume here, V, is equal to pi. The integral from x is equal to 0 to x is equal to 1, y squared dx. Now, y is equal to 2 over 3x plus 1. So that's 2 over 3x plus 1, which is the same as saying 2 3x plus 1 raised to the minus 1 power. Now, y squared is therefore equal to the square of all of this. So it is 2 3x plus 1 to the minus 1 square, which is 4 into 3x plus 1 to the minus 2 power. So therefore, the volume V would be equal to, let's bring the 4 outside, 4 pi, the integral from 0 to 1 of 3x plus 1 to the minus 2 dx. Now, this is 4 pi, so let's integrate. This is a linear factor. We're going to have 3x plus 1. We're going to increase the power by 1. So it's going to become minus 1. We're going to then divide by the new power, which is minus 1, and also divide by the differential of the inside function. And the limits are 0 to 1. So what we end up with is minus 4 pi over 3. Then inside the bracket, this is 1 over, I'm going to replace 3 with 1. So it's 3 times 1 plus 1 minus 1 over 3 times 0 plus 1. So continuing, we're going to get minus 4 pi over 3. Inside the bracket, I have 1 over 4. 1 over 4 minus 1. If I take away 1 from a quarter, I'm going to get minus 3/4. So this would be equal to minus 4 pi over 3 multiplied by minus 3/4. The 3's cancel, the 4's cancel. A negative times a negative is a positive. So the final answer is pi. The final answer is pi. Final answer is pi cubic units. All right. Next example. Example 21, it says the curve y is equal to sec x over 2 is rotated 2 pi radians about the x-axis between the limits x is equal to 0 and x is equal to pi by 3. Show that the volume of the solid form is 2 root 3 over 3 pi. All right, so this is a show. First of all, such a volume V would be equal to pi, the integral from x is equal to 0 to pi by 3 of y squared dx. Now y is equal to sec x over 2. If I square both sides, I'm going to get y squared is equal to 6 squared x over 2. So the volume V would be equal to pi, the integral from 0 to pi by 3 of sec squared x over 2 dx. Now, when I differentiate tan, you get sec squared. So if I integrate sec squared, I'm going to get tan. So the answer here becomes pi, and over here I'm going to have tan x over 2. Then I have to divide by the differential of the inside function, which is a half. All right, and this is from 0 to pi by 3. Now, dividing by a half is the same as multiplying by 2. So I'm going to bring that 2 out, as in 2 pi. And then inside the bracket I have, I'm going to then replace x with pi by 3. So this is the tangent of pi by 3 divided by 2 minus the tangent of 0 divided by 2. All right. Now this becomes 2 pi, and inside the bracket I have the tangent of pi by 6. All right, and it's going to be minus tangent of 0, which is 0, so we can leave that out. And we've got the limits here, 0. Oh, there's no limits. We've gone past that section. All right. Now, pi by 6 is 30 degrees, and the tangent of 30 degrees is equal to 1 over root 3. I'm double checking it in my mind's eye. The tangent of 30 degrees is equal to 1 over root 3, which is root 3 over 3. So this is 2 pi times root 3 over 3. And so our final answer is, so our final answer is 2 root 3 over 3 pi cubic units. All right. So the last part of the question required, or the question was required us to show that the volume was equal to 2 root 3 over 3 pi. All right. That's what we're asked to do. We just did it. So the question is complete.